Hello everyone. Uh, Today I would like to present my research works. I introduce myself a little bit. My name is Suabsakul Presentation. I am a graduate student from Faculty of Informatics, Burapha University, Thailand. And I also have my colleagues, Dr. Wacharapong Yukwan, Dr. Atita Oneur, and Dr. Krisana Chinasan. Today I would like to present my research work, burglary risk analysis in Sriracha police station areas using the network analysis and the GIS. So I would like to introduce a little bit about my research work. So my research work is related to the burglaries. So burglary in Thailand is the big problem, and I think it's gonna be same the big problem around the world. In Chonburi, especially my area is Sriracha area. It can show many of the criminals because of what? Because in this area there are many tourism industry and the logistic, and also the Sriracha area is a dense of the EEC or Eastern Economic Corridor. It is a Thailand flagship growth zone concentrated on industry, logistics that can drive investment and job in this area. It means there are so many people work in this area and also the hub of the heavy daily movement on the road, on the car and the vehicles. So we can see the challenging problem about the crime and a lot of people in this area. We can find that there are two core challenge problem in the EEC. First thing is about the roads because of the highly connected roads and enable to fast access and fast escape along key corridor like for example Sukhumvit Road and the motorways, which are the main road from the Bangkok to the eastern provinces like Chonburi or Rayong. The burglary patterns in the area exploit high connected connectivities corridor because it can fast entries and fast escape. The bad guy can go make a bad thing and can go easily. The second challenging is we have the limited of the police patrol and the CCTV resources. So because we cannot provide the CCTV cover full scale in our area. That's why we have the problem. Next is become the motivation and objective in my research. Because my research, I would like to find the burglary hotspot in our Sriracha area. And also we try to combine the map and the graph theories with the social network parameters between the centrality or BCs. This parameter used to analyze the social network metrics, and we use to evaluate the criminal risk in this study. Next is I would like to talk a little bit about the theories and specialists on the social network parameters. Based on our literature reviews, we find two interesting papers. One is Devin Bishop in 2013 and Davin Johnson in 2015. They study and validate the between the centralities for crime risk mapping in UK, especially in the London area. And they can show that if there is a high value of the between the centralities, the criminal is also high as well. After we have an idea, we're gonna show you the methodologies, what we are study and show a little bit data pipeline. First of all, we talk about the data acquisitions. We have to extract the data from the road, from the OpenStreetMap, and we also have the reference crime incident data for validations in two locations. One is Plapachai 2 and another one is Sanasongkham police stations for validations. After that, we're gonna process the data by convert the GPS layers into the graph, edge, and node. Then we're gonna calculate the betweenness centralities in terms of normalized one. And after that, we're gonna integrate all the data link from the GPS and the between the studies, and we're gonna plug in together. And after that, we're gonna analyze the model. We use normalized between the centrality to access the road network in our Sriracha area. Also, we're gonna validate the data. We're gonna show the result that we compare with the reference data from Chana Songklam and Papachai to confirm the model validities. Finally, we're gonna show the road that is a hotspot in our Sriracha area to represent the risky locations. This is a flowchart. Roughly, I'm gonna show you very short. First of all, we have the two validation location, Chana Songklam and Papachai 2. And then we have a OpenStreetMap. We got a raw map, and then we convert into the graph, node and edges, and then we calculate the between the centralities. After that, we have to validate with the real incident data and see the pattern of the criminal and the between the centrality is related each other or not. And if it's valid, we're gonna study on our present study at the Sriracha, and we show the results, and after we have a short discussion and the conclusion for the papers. First of all, we're gonna show some results from validations. Result number 1 from validation at the Chana Songklam police stations. On the left side is the data from Pon Kamnat Sap in 2014. As you can see, the red spot in here is a location where is incident crime. The burglaries happen in the area. It's alongside with the 3 roads, Pratit Road, Pasumen Road, and the Samchen Road. As you can see here, we're gonna compare with our results from the between the centralities. As you can see, the highs between the centralities also alongside with the 3 road. We can set up the threshold is around 0.5 minimum maximum between the centralities is on the green line, yellow, orange, and the red over here. I think it looks consistent with the incident data from the Pon Kamnat Sap. So next, for the results number 2, we validate with the Papachai police stations. On the data of the put in 2019, it's same. The red spot is a high incident crime on alongside with the 2 roads, Yawarat and 1:1. After that, we make the simulations on the right side. You can see the highest locations is on alongside with these 2 roads, and we can see a little bit highest on the crossroad over here. But the trend of the criminals is look similar over here. After these 2 results, we can indicate that where the location has a high between the centralities, it could represent the highest risky of the burglaries or the crime. Next, I'm gonna show the result from the present data, the Sriracha police stations. On the left side, this is a map. After we convert from the street map into the graph, node, and the edge over here. And after that, I calculate everything into the normalized between the centralities. From the minimum scale is 0 to the maximum scale is 1. So it's not look clear to see over here. We have to filters at the 0.5 to see the very high and the risky road over here. After the filters, as you see the red line over here, the locations where the between the centrality is higher than 0.5. From the map, we can see many roads that I show in the figures. There are 7 roads with a risky location. First of all, highway number 7, Nong Tayai Road, Sriracha Nong Yebu Road, Sriracha Nong Khaw Road, Sriracha Map Yeng Road, SR Lower Road, Sukhumvit Road, and Assumption Road. These locations, which is high between the centrality, we can be conclude that this road gonna be the risky one and will be the hotspot for the criminals. And after that, we go to the next part is the discussions. After we see the uh, risky hotspot on the road, we can perform the police patrolling on this key road which has a high between centralities. We can enhance the police patrolling and make a focus patrolling on that key roads. After we have the limited of the budget for each year, I think the local government can install more CCTV in high risky and risky spot and also install the light in this hotspot as well. For the conclusions, after we study, we can think that after by validations, it can confirm that this parameter normalized between the centralities, there is an effective. If that area has a higher between the centralities, it can show the greatest burglary risk. Also, after we have results, the normalized between the centrality results should inform the operational planning for the police patrolling route at these high locations. Also, for the local government, they can deploy the CCTV, the lining in our high risk area. Okay, thank you for your attention. I'm sorry that I'm not able to come and present on site. So if you want some further information, please contact my email over here. I'm pleased to answer your all questions. Thank you very much for coming today.